welcome back to Sunday Science. My name's Aditi.
And my name's Aditi too. It's a pretty popular name.
Today's Sunday Science is why birds don't get electrocuted while on top of a wire.
It's pretty interesting, actually. Hope you enjoy.
Oh my gosh, it's so beautiful outside today.
Hey, look over there.
Hey, how come it's just like sitting there?
And why isn't it getting electrocuted?
Let's find out on today's Sunday Science.
Electricity is a form of energy resulting from the existence of charged particles, such as electrons or protons, either statically or as an accumulation of charge, or dynamically as a current. Electrons need a closed loop. This loop is necessary in order for electricity to move. There are two important aspects of electricity, one of them being current and one of them being potential. But we'll talk about current later. In order for electrons to move, they also require a difference in electrical potential. To simply say, electrons move from a higher electrical potential to a lower. We will explain this using the example of a waterfall. Say there's a lot of water on top of a hill and there's this giant boulder blocking all the water. Once that boulder is removed, all the water will rush down to the bottom. This is the same as how electrons move.
Electric current is a stream of charged particles, such as electrons, moving through an electric current or space. We can use a river as an example. The water is the electron. The water moves in one direction, and it takes a lot of force to change that. Also, like a river, the electrons will go through the path with the least resistance. Like if one path has rocks and the other has nothing, the electrons will go through the second one.
In today's experiment, we will be measuring voltage, current, and resistance. To start off, we will be measuring voltage. Here, I have a battery pack, and here I have a multimeter. Since I have connected my multimeter and my batteries, and each of these batteries is 1.5 voltage. So, if all four of these batteries should be 6 voltage. But it is 4.79. That is because we have used this battery pack before, multiple times, so it will be a little less.
So we just measured voltage and now we're going to measure current. To measure current, you need to make a circuit as we've made right now with the light bulb and the battery. As you can see on the multimeter, the reading is 0.33 milliamps.
I'm going to be using this multimeter to test out the conductivity of objects. If the multimeter beeps, then that means that the object is a good conductor, and if it doesn't, that means that the object is not a good conductor.
Some objects are better conductors than others, and objects that aren't good conductors are referred to as insulators. Let's check with the steel fork.
The multimeter is beeping, which means that the steel fork is a good conductor, and it also has very little and minimal resistance.
On the other hand, let's check with this wood object. As you can see, the multimeter isn't beeping, meaning that the wood is a very good insulator or a bad conductor and offers resistance to the current.
Now that we've learned about the basics of electricity, let's find out why birds don't get shocked on power lines. Well, the reason for that is pretty simple. When birds sit on wires, there is no difference in potential. Power cables usually have a difference in potential, so if birds sit on one power cable, there will be no difference in potential. Thus, the birds won't get shocked. But if they only sit on two lines with differences in potential, they will get shocked. But there is also another reason why birds don't get shocked on power lines. You see, electricity likes to flow through the path with the least resistance. The example we offered earlier, electricity is a lot like water. It will want to flow through the path with the least resistance. The resistance a bird offers is higher than of the power line, hence the electric current does not pass through birds.
Now that we know that birds don't have some sort of superpower that enables them to sit on power lines, is it even possible for them to get shocked at all? Well, yeah, it is possible for them to get shocked. We learned that if they sit on one power line, they can't get shocked because of the potential. But if they sit on two power lines simultaneously, the potentials in these two power lines are different. and the current will immediately try and correct this by going through the bird. The bird will get shocked in the process. This goes for another situation, like for example, if the bird were sitting on the power line as well as a pole. Again, the pole and the power line have different potentials, and the bird will get shocked while the current tries to correct this. Birds aren't the only thing that this situation applies to. This applies for humans as well. If a person were to touch a power line while also touching the ground and the power line have different potentials, and the human will get shocked. But if a human were to hang from a power line without touching anything else, they won't get shocked, because there's only one potential and the current will not flow through the human.
Wow, that was really interesting.
I totally agree. I love the skit part.
Well,
Hope you enjoyed
and see you next Sunday on
on Sunday Science.